Hey everyone, welcome back to Python DevOps. In the last video, we covered Terraform data types, how Terraform store and work with string, number, list, map, and so on. Today, we are going to take that knowledge further and talk about loops. Loops in Terraform let you stop copy pasting resource block and write infrastructure that actually scales. By the end of this video, you will understand three things: count, the index based loop, for each, the key based loop, for expression, collection transformation. Theory first, then we will jump into a live demo with real AWS resources. So let's get into it. So first, the problem. Before we look into the solution, let's understand the problem they solve. Imagine your team need one S3 bucket per environment, dev, stage and prod without loops. You write this three separate resource block, one for dev, one for stage, one for prod. Each block look almost identical, just a different name. Now look at the problem column on the right. So these are the problem. If you need to add a fourth environment, disaster recovery, for example, you manually add another block, copy paste, tweak the name. If the bucket config change, encryption setting, version, lifecycle rule, you edit every single block. Three edits, three places where they can drift. The more bucket you add, the more likely one of them get out of sync with the other configuration, and all that violate a principle you have probably heard of, DRY, which stand for don't repeat yourself. This is exactly problem Terraform loops are designed to solve. So next is the solution. Loop once, deploy many. Here is the same three bucket: dev, stage and prod. One variable, hold that list. The bucket name is dynamically constructed using each.key. We will explain what that mean in a moment. Now if you need a fourth environment, look at the bottom of the slide. You can change one line, just add dr to the list. Terraform handle the rest. Config changes? No. You make them in one place, the resource block, and every bucket gets the update on the next apply. That's the power of loop. One block, any number of resource, data driven and easy to change. So these are the feature. Next is three loop mechanism. Three way to loop in Terraform. Terraform gives you three tools. Let's get a high level picture before we go deep on each one. First one is count. This is the simplest. You set count equal n and Terraform creates n copies of the resource. Each copy is identified by a numerical index starting at 0. That's count.index. Use it when you need identical copies and the order doesn't really matter. Second one is for each. More powerful, you give it a map or set and Terraform create one resource per item. Each resource is identified by a string key, which is each.key. You will see upcoming slide. Use this when your resource have meaningful name or different configuration. Last one is for expression. This is the odd one out. It does not create resource. It transform one collection into another. A list into a different list, or a list into map. You use this in local variable, default and output. Think of it as a data transformation tool, not a resource creation tool. Keep that distinct in mind. It's a common source of confusion for beginner. So next one is count, how it works. Count, index with repetition. Let's go deep on count. On the left, you have got the syntax. We are creating an EC2 instance. So here we are creating AWS instance. We set count equal 3. That's it. Terraform will run through this block 3 times. The loop variable in count.index. It start 0 on the first iteration, 1 on the second, 2 on the third. We use it in the name tag, as you can see here in the name tag. Count.index with the dollar and the curly braces. So we use it in the name tag to give each instance a unique name. Web server 0, web server 1, web server 2. On the right, you can see Terraform actually create the resources. Three resources address as AWS instance web 0, web 1, web 2 with the name web server 0, web server 1, web server 2. At the bottom, how do you reference one of these from an output? So I have given the output condition that if you want to print the 0, then AWS instance web 0, and if you want to print any output like public IP, ARN or anything, so that's how you're gonna take the output. Simple, clean, work rate as long as you are aware one of the important gochas. So next is count the index shift gochas. This is the most important thing to understand about count, and the reason many teams avoid it for anything with named resource. Imagine you have three instances. Index 0 is dev, index 1 is stage, and index 2 is prod. Now you remove stage from the middle of the list. What does Terraform see? It sees that index 1 used to point to stage and now point to prod. Index 2 is no longer exist. So the plan says destroy web 2, update web 1, but web 1 is now prod. Terraform is going to destroy your production server because you removed staging from the middle of a list. This is the index shift problem. It happened because Terraform track count based resource by position, not by name. The rule of thumb at the bottom: use the count when all instances are genuinely identical and you rarely remove item. If your item have name, environment, region, account, use for each. Instead, it does not have the problem. Next is for each. How it work? For each key based repetition. Now for each, this is one you will use most in production. For each accept two type of input. Maps is in key value pairs. On the left of the variable instance is a map. So here we define the map. Where can each key is an environment. So these keys are the environment, and each value is the instance type. Means these values are the instance type. Where we set for each equal where dot instance. Terraform create one instance per map entry. The instance type comes from each data value. So instance type is each dot values. These are the keys. So names are coming from each dot key. So how it work? If you define the map, so you take the input dev equal t2 micro, prod equal t3 small. So what Terraform do? It create instance called app. So AWS instance dot app dev is instance type t2 micro and name is dev. If you created the instance for the prod, so take the name prod, and AWS instance dot app is prod is instance type t3 small. So this is for the map. Let's go for the next input type, which is sets. Unique string, if you just have to add a list of a name and no associate value. Wrap it in toSet function. For each sets unique string, if you have a list of name and no associate value, wrap it in it. So use toSet function. For sets, each.key and each.value are same, both equal. The set element. On this section you can check I have created AWS S3 bucket with the app. For each I've used with the toSet function. So we got three key or the values, which is dev stage prod, and use the name bucket each.key. You can use via each.key. So how it works, basically we can see here we have the three input dev stage prod. So it will create for the AWS S3 bucket dot app. For dev environment is my app dev, same for the prod and same for the stage. So that is how it work. So quick summary is there: define a map or set, for each loop over it, create one resource per element, use each.key and each.value. So that's how it work. So let's go to the next topic. For each no index shift. So we have a problem which is no index shift. Let's replay the same scenario. Removing stage, but this time with for each. Before three bucket keyed by dev, stage and prod, we remove stage from the map or set. After two buckets, dev is untouched, prod is untouched. but you have removed the stage 1. The Terraform plan is exactly what you had expect. Destroy the stage bucket and nothing else. Why? Because each resource is tagged by its string key, not a numeric position. Removing stage only affect the resource with the key stage. Everything else is completely isolated. This is the predictable, safe, and exactly the behavior you want in production infrastructure. The problem line when item have meaningful name always reach for each. So next is for expression. For expression transform collection. Now the third tool, the for expression. First the syntax, two forms. So let's see the syntax. You have to use the square bracket, then for item in list, and then you have to give the expression. It's produce a list. If you want to produce a map, for item in list, then colon, then key, and then equal greater than symbol with value. It produce a map. So that's how you can produce a map or a list. So list to list transform each element. We take var.environment and apply upper function to each item. Input in lowercase, output in uppercase. List to map if you want to build a lookup table. So for each environment, we produce a key value pair. The environment name map to bucket name. Output is map. You can look thing up in. What an if filter. If you want to apply a filter, exclude some item. The if close at the end filter the collection only item where the condition is true. Make it into output. The key rule. Square bracket gives you a list. Curly braces give you a map, and the expression never create infrastructure. So this is for the for expression data transform. The practical use you can see I have given the in local derive a list from a variable. I have given the local section which I have already teach you into the previous video. So give the bucket name, and this is the output we can take for e in variable.environment and then colon var.app and give the dollar with e. So that's how you can use the into the derive form. In output reshaping resources data. This is very common pattern. You have a map S3 bucket created for each, and you want to output all their ARN as a single map. So for k v, k is for key, v is for value in AWS S3 bucket dot app. So we got the key and the value as an ARN. So we put the v dot ARN. So result will be dev ARN, stage ARN, prod ARN. Okay. Feeding for each, combining with two set. Remember, for each needs a set or map, not a plain list. You can use a for expression with filter inside two set to build exactly the set you need. Keep this remind in your mind. For expression is data transformation, count and for each are resource creation. They work together, but they do current or the different jobs. So next is count versus for each slide. So count is a number, for each it has a map or set, whatever you define. So resource address, so we can set resource 0, resource 1 means by the numbers, but it is by the keys like dev, prod. Basically we have the string. If you shift the index, may destroy other resource, but if you remove the key, it is safe. It destroy only those resource which you want to delete. And we have a different config. No all copies share the same block. Use each value for per item. N identical copies replica spare VM. Named item env region account. Next is key takeaway. So quick summary before we hit the demo. Count use for analytical resource. Your loop variable is count.index, start at 0. Watch out for the index shift problem whenever you remove item. Next is for each, use for named resource, accept map or set. Use each.key and each.value. Safe to remove any item, other are unaffected. Next one is for loop with transformation data, does not create resource. If you use the square bracket, it create the list. If you use curly braces, it create the map. Use in locals output and to feed for each as well. So I given the rule item have names, for each just need n copies. Count need to reshape data for expression. So I have given the rule as well. Log those 4 rules in and you will make the right choice every time. So that's all. Okay, what will what we will build in the demo. The demo coming up, demo 01, count with EC2 instance. We will create 3 identical EC2 instance. Use count.index. Demo 02, for each with S3. We will define a map environment and use for each to create a bucket per environment. And demo 03, for expression in outputs for every resource, whatever we create. So we will meet into the next video. So if you like this, hit like and share. Thank you.